few seconds. At least the stream will be up on YouTube. I'm live right now. Cool. So yesterday we were doing Fluent, right? Fluent dot xyz. Let's go back the docs. Okay, great. Uh, we are on the docs. Yeah. So yesterday we did this. The what? The Solidity app, basically on Fluent. Today we are gonna do this uh, blended app, this part. So for this blended app, this let's go let's try to go through it, and I have few questions that we should note down, and maybe I'll ask them in Telegram. Their Telegram, they have Telegram like any other project, Builder Telegram, I think. The name is Telegram. Uh, just a second. Let me find it. Fluent, yeah, Fluent Builder Chat or something like that. I don't know where to find them, where to find that link, but probably it should be somewhere in the docs or in here somewhere. Or you can join the Discord. That's great too. Okay, let's start with this. Building a blended app. Introduction. This guide provides detailed instructions on how to build a blended Hello World application on Fluent. It combines REST contracts. uh, It combines a REST smart contract to print hello and Solidity smart contract to print world. This setup demonstrates composability between different programming languages, Solidity and Rust, and interoperability between different virtual machines, targets, EVM, and WASM within a single execution environment. Okay. Prerequisites: ensure you have following installed. Node.js, I have that. Rust, I have it. Hard hat, I have it. This, I don't. PNPM, PNPM. Okay. To VS Code, let's install it. Okay, package added. Cool. PNPM, PNPM-V. Okay, it is installed. Browser, install Fluent Scaffold CLI. We have done that yesterday, so you can just say, okay, let's go to VS Code, and we can create cd dot dot mkdir Fluent blended app, and now we can go to that folder, blended app, and instead of doing this, what we see in the browser, doing all these things, we can just try their command line, like um, gblend init, and they have blended, you see, blended app. So that's what I want to try, and It created, yeah, I think it created everything that this uh, page says. So let's open cargo terminal and cross check this. So here it says create a new project basically called greeting, and we have it here. So greeting this part, this folder. Then car- cargo.toml, everything is here. See, all these configurations are on our in our cargo.toml. So Fluent base SDK, that's the rest of the things are there. Okay, write smart contract. It is already written. So if we check lib.rs, it's same, and we can read the code explanation. So whole explanation is here. I can't open two two tabs side by side because it will take me some time to figure that out. Okay, ignore that. Let's just read this detailed code explanation. This line is a compiler directive. It specifies that if the target architecture is WASM32 WebAssembly 32-bit, the code should be compiled without standard library, no underscore standard. This is necessary for WebAssembly, which doesn't have a full standard library available. Okay. Extern create alloc, extern create fluent sd, fluent base underscore LTK. These lines declare external crates libraries that the code depends on. Alloc is core library that provides heap allocation functionality. Okay, like heap and stack. Base, if you are familiar with any kind of programming, you know what is heap and what is stack. So I don't have to explain that. Fluent base. Let me zoom in. I think, yeah, zooming in would be much better. Fluent base SDK is SDK provided by Fluent for writing smart contract, writing contracts. Use alloc string to string. Okay, string comma to string. This line imports string and to string types from alloc crate. This is necessary because the standard library, which normally includes this, is not available in no standard environment. Okay, so these things are not available. That's why we are importing them. This whole import, this is also import. So let's read this. This line imports various items from Fluent base SDK. Great. Base entry point. It is a macro for defining the main entry point of the contract. Macro is a Rust concept, router and function ID. Our macro is that routing function calls and defining function signature. Cool. Go back to lib. We understood all this, and we were reading about router and function. Where is function ID used? Yeah, function ID. So this basically defines the function ID. Sorry, I was saying this defines the function ID for Solidity. So you see, router macros for routing function calls. Okay, so this is a router API. We have a router here also, and router mode. Sorry, this is the macro they are saying. Small router. Yes, I'm pretty sure that's this is the macro. It defines how the environment will route route the function call. So we are calling from Solidity. This is the Wasm contract, right? Other contract will be Solidity. So we are telling this contract that if a function calls, it will be Solidity, and if you see this function ID, execute this function. So something along those lines. Not sure if it will be same. Not sure I'm correct or not, but that's my understanding for now. As we go ahead, it might change. So keep that in mind. Contract rate enabling contract functionality. So it tells this is a contract. Is that it? Yeah, probably. Shared API is the trade that abstracts API shared between different environment. Back to VS Code and shared API. So shared API is basically each of the contract deployed for different VMs will have one thing in common, and that's how they'll interact with each other. And shared API is that component. Okay, derive contract struct router. This line defines a struct name router and derives a contract implementation for it. The router struct will implement the logic for our contract. Okay, correct. We can see the say that we can see that in the code also, right? So this is the router struct at the top, and here is getting used. What next? Okay, pub trait point 6. This is the code, and this defines a trait named router API with a single method greeting. This method returns a string. So trait is like an interface, probably. Point 7. The block implements this block implements router API trait for router struct. The attribute the attribute indicates that this implementation is for Solidity compatible router. Okay, so now we understand. So will there be multiple implementation for multiple environments? How will this work if it's a Viper contract? Okay, let's move ahead. We can note down these things as a questions. So question first, if if where was this? If attribute indic- indicates this is the implementation for, where is this? This is the implementation for Solidity. Then what happens when a developer uses a Viper contract with it? Question mark. Will it will it still work or no? Or no? Answer probably yes, but but still need to cross check. Cross check. Okay. So let's go back to their explanation. It tells Solidity compatible router inside the implementation function. Function ID. We are using function ID. What was that? Function ID was the macro. Okay. Function function ID macro specifies the function signature and Solidity syntax. This tells router how to call this function from Solidity. Okay, that's awesome. Function greeting SDK shared API self string hello dot string 2 is the implementation of greeting method which simply returns string hello. This is the point 8. This block provides an additional method deploy for router struct. This method can include custom deployment logic. Currently, it's an empty placeholder. Okay, we can deep dive on this if they give us an example. Yeah, so let's write that down. Is there any example of custom deployment logic? This is to learn how that method works. Also, other question, one more question was this: Arvasm reduced wasm. Where can I read more about it? Question mark. Okay. So yesterday we had this issue, right, where we didn't know how this might what this was, and in the docs there is no clear details like what Arvasm is. Basic and okay. Point 9 basic entry point. This macro invocation sets up the router struct as the main entry point for the contract. It handles necessary boilerplate code for contract initiation and invocation. Understood? This Rust code defines smart contract that will be compiled to WebAssembly. The contract implements a single function greeting that returns the string hello. The contract is designed to be called from Solidity environment, showcasing interoperability between different virtual machines. Only two right now, which is Arvasm and EVM, showcasing interoperability between virtual machines. The basic entry macro ties everything together, making router the entry point of contract. Cool. Build Wasm project. Let's run that. Gblend blend build rust dash r. Oh, not found. Let's cd into the project, the folder which is greeting, and then run the command. It will take some time, so let's wait for a while because oh okay, 18 seconds. Now do we have a new folder here? Yes, target, bunch of things, wasm unknown, release, debug. Okay, can we see what else is there? So release, we built a release version, path default. We could have passed the path to create a .wat file, .wasm file, verbose show logs, help, okay, version, okay, environment file. Why would we need an environment file here? Instead of Rust, can we just see for build? Okay, there are only two commands. One is Rust, one is help. Okay, that's good enough, I guess. What's next? One question I had was, yeah, why do we need this environment, and where might we use this? G blend build rust command had option to pass e environment variable environment variable, but I don't know in which scenario we might need .env file for contract that will be deployed on chain. The only issue here is that I don't understand why we need environment file. Uh, if we are publishing contract on chain, and hopefully we are, this Rust contract doesn't really have anything private. So why use env variable? It would have been different scenario if deployment command, like deploy command, uh, had .env file, because it makes sense. We need a private key to deploy, but we can't use. We need private key to deploy, but we shouldn't store it in any file, right? Every all the secrets, like by it's a standard, right, where we put all the secrets in .env file and use that. So in that context it would have makes sense, but here it doesn't. So we have four questions for the developers, or the Fluent team, where um, I don't particularly understand these issues, but there is no documentation for it. Back to our docs. Solidity project, we already have initialized it. Yeah, we need to run pnpm. Let's see, pnpm. It has this. Okay, so we can run npm install or npm install and see. It's just running the command and installing everything. Oh, cool. pnpm. The this style is good. I don't like npm. npm just puts a lot of text here. This was pretty interesting to see. Back to browser. Here we do we have hard hat config. It's already created. Package.json. It's already there. .env file. Okay, in this we need a deployer private key. Cool. I'll change the screen and just put the env variable there. Just a second. Where was this? Yeah. 0x, then the private key. Let's go back. Okay, we can just read this and then we can move to next step. Replace your private key or understood. Write the Solidity contract. In this section, we'll create two Solidity smart contract. I Fluent greeting and greeting with hello. Okay, this interface contract allows the Solidity contract to call REST functions, demonstrating interoperability between Solidity and REST within a single execution environment. With final greeting with world contract provides a composable solution that combines output of both REST and Solidity contracts. Create contracts, we already have this. This is just interface which tells greeting. So this is for our Rust code. We saw in the Rust contract we had a function called greeting, and at the bottom here with I Fluent greeting, we are just defining that what that function is and what it returns, and rest of the things like view, external view, etc. Interface function, the ifluent greeting interface declares a single function greeting that is external and viewable, meaning it does not modify the state of blockchain and returns a string. This function will be implemented by another contract and is used to interact with Rust contract, Rust smart contract. Yep, that's what I said basically previously. Interacting with Rust code, the greeting function defined in the interface matches the Rust function that returns a greeting message. The Solidity interface allows Solidity contract to call Rust smart contract function. Then we have greeting with soul. Okay, uh, defining pragma directive, importing that uh, interface, creating a global variable. Here we need to send the address which will get after deploying, so we need to keep that in mind. Next, greeting view return. Okay, it calls this contract g fluent greeting contract dot greeting. This is just function, it will return a string, and this function get greeting also returns a string. So we are just packing those two strings together. This will return hello, and we have here world. So get greeting will return us hello world at the end. Okay, see, I just explained this part. Interaction with Rust code. The greeting with world contract interacts with Rust smart contract by calling greeting function via Fluent greeting interface. When get greeting is called, it fetches greeting message hello from the Rust contract, concatenates it with world, and returns the complete greeting hello world. Okay, this is not the exact greeting, like there is no comma, there is space. um, i'm I'm just splitting here, but I know how solidity solidity and rust interact. Okay, that this is interesting for us. Rust smart contract deployment. The Rust smart contract is compiled to Wasm and deployed to blockchain. It contains a function that returns the greeting hello. Solidity interface. The Solidity interface declares a greeting function that matches smart contract. Okay, this is not explaining how it interacts. It's just telling the process. We already know that. Deploying both contracts with hard hat. This deployment script is responsible for deploying both the Rust smart contract compiled to Wasm and Solidity smart contract. Greeting with world. Deploy this bunch of imports configuring .env. It is taking the private key. If there isn't one, we already have it, so we don't need to worry about it. So I don't know if I need to add 0x or not in front of key, because here they are not adding it. Okay, if we get an error, I'll remove the 0x that I have added right now. Okay, this is const function deploy function async hard hat something, creating bunch of constants, deployer address, deploying wasm contract, path of the binary. I don't know if we have. Yeah, we do have it. So I guess when we built it at the start, it created all these things, but also this file lib.wasm. It should be somewhere in this. Yeah, in the release or in the target folder, but I think the command copied it in the greeting folder. Back to our script. Const provider, it's just RPC, then we have the wallet, then checkmate validator address. I don't know why we have added that. Wasm binary deployer provider, then deploying this. So this is basically our uh, what is our Wasm contract address. You see, we are setting it here and passing it as a constructor argument. So that's pretty simple to understand. We are deploying the contract. This is the contract, deployer address, constructor arguments, and if we want logs, probably. But I don't know what this exactly does, but by just checking this, just by common sense, I'm pretty sure this returns us the log of deployment, if there are any logs. Then console log here. Yeah, wasm deploy. This contract is this function we have here. It just does wasm it gets the file, then gets the hash of the file, artifact name, wasm binary, existing deployment, artifact name, get or null. If existing deployment, metadata hash binary, wasm bytecode has not changed, skipping deployment, existing contract address. artifact. So these functions, we generate a binary hash, then we give that artifact a name, and they are somehow checking if that artifact is deployed on the blockchain itself. So binary hash dot wasm will be the identifier, on-chain identifier that for that particular contract. Next is just checking it. Sorry. Um, yeah, then gas price transaction. It says something, something, something. We are creating a transaction object and then deploy, sending that transaction object, waiting for it, receipts. Understood. If receipt and if receipt dot contract address, console log this artifact deployment data, save is, I don't know, await save. Is it TypeScript function, Node.js function, hard hat function? I don't know, but it saves this whole data. Throw error, okay. Export function, understood. Create a task. Okay, it basically gets the greeting from the contract. We can do and pnpn pnpm hard hat compile, then deploy, and then greeting. Okay, back to VS Code. We saw which was pnpm hard hat compile. Also, all the scripts we saw and the tasks, they are already here. Oh, okay. Um, Also, that's the test environment. So test private key. I'm anyway gonna delete that. Task. The whole task is here under, and deployment script. This is the deployment script. In the hard hat config, okay, it says deploy, but where are we? Okay, let's try to run it. Compile pnpm hard hat compile. We have this, then deploy. Nothing to compile. What was the error? Error in processing, insufficient fund. Okay, let me switch. We had fund yesterday, so maybe I should remove this 0x. Close this. Try to deploy again. Insufficient fund for intrinsic transaction cost. Deployer address is this. Back to our browser. No, 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 no. I want to open a new tab and address. Why does it say insufficient transaction cost? Because we do have some balance. Probably insufficient funds you have and want this much. Oh, okay. Can we, in the script, are we setting a value somewhere? I guess limit instead of 300 million, let's say, let's make it 10 million. Will that work? Yes. So, okay, you saw uh, default values that are there are too high. Maybe the person who created this demo, they just had a lot more ETH and they didn't figure this out. The this error might happen. They didn't foresee that. Okay. Next next step was pnpm get greeting dash dash contract and the contract address. Pnpm get greeting dash dash contract and then the address. What? Oh, pnpm hard hat, and we get the greeting, hello world. That's cool. Okay, so now few questions I had after I was just thinking about how this might work, because we know there is smart contract interoperability. You can deploy any smart contract, but what will happen for the front end? If you see in the docs, it talks about everything: Fluent base framework, uh, Fluent L2, Fluent VM, all these things. We are going to read it tomorrow, but for now, I want to talk about a few things where, even though we are allowing developers, like not we, but Fluent is allowing smart contract developers to deploy different smart contracts on a same chain, and those smart contracts can interact with each other. But will that same thing happen on the front end? That's the question. Where Solana front end, by just changing RPC, will work on Fluent or not? Or they have to modify the whole front end according to Fluent? That's a genuine question where I don't know the answer for this. So I am adding it to our questions. Fluent Fluent allows for smart contracts to be different smart contracts: Rust, Solidity, Viper, to be deployed on same chain and interact with one another. What happens for the front end of those apps? Question mark. Will Solana front end chi- will Solana front end work on Fluent by just changing the RPC? So that's a good question, because dApps are not just like backends or smart contracts; they are also front end, where we do need to understand this. And another question was, when we deploy this WASM contract, where was WASM? Yeah, this is the WASM or WASM contract, right? But this looks like a Ethereum deployment. So if a developer deploys a Solana smart contract, will the address have the same structure? Because there will be some differences where S- Solana contract can't directly talk with Ethereum contract. If every address is WASM, every address is following EVM structure, so 0x something something, and SVM contracts, SVM addresses don't follow that structure. So how that will work? We have seen uh, from one way to another, where here you see we are calling the WASM contract from Solidity, but we can call solid Solidity contract from WASM, but that example is not here. So maybe tomorrow we can write it, probably. If not, I'll we can add it here. So is there example of how WASM contracts can do a function call to soli, so- solidity contracts? Question mark. Or should we build one by digging deep in deep into Fluent base, Fluent base HDK? Also, address structure of all contracts. No, will address structure of all contracts deployed on chain on Fluent be like EVM addresses? If so, how? No, we'll put it here. We'll ask only this question because this is more important. The Fluent base can handle all the contract, all the changes, and when they put SVM thing, SVM, what was that? SVM demo in the docs. We'll read about it more. Okay, cool. So today we saw an example of blended app. I know we just went through their docs and didn't do anything specific, but at least you got a chance to look at it. Yeah. because these things get put on back burner, and you might forget it, like you, similar to how you forgot multiple interesting projects. But that's why I'm trying to do this, where I want to go through docs of interesting projects, and Fluent was the first one. um, okay, cool. Fluent, we saw these all these demos, went through docs. Tomorrow we'll go through rest of the pages and see what things are there. Okay, cool. I hope you like the stream, and you'll be here same time for tomorrow's stream. You know the topic, and hopefully you are excited about it. Okay, cool. That's the stream. Have a nice day, and bye.